Do you remember how to do volumes? Sure, you remember. Let's take the easiest one we've got, which is this one right here. You know that that is a nice rectangular prism, so you know that the volume is length times width times height. But there is a pattern that I want you to remember, and it's this one. The volume here is actually whatever the area of the base is times whatever the height is. What are you talking about? Well, look, here, length times width is actually the area of the base. There's length, there's width, right? And then all you have to do is multiply it by the height. Well, that's where the length times width times height formula comes from. And this becomes a lot more versatile all the way across the board, no matter what kind of object you're dealing with. Case in point, look at a cylinder. Look at this guy. There's the base. You know that the area of this base is pi r squared. And guess what? There's the height. So the volume is pi r squared, the area of the base, times the height. Take a look at this one, for example. Look at this. This is a triangular prism. Oh my goodness. We can find out the area of this base. Well, we know the area of this base is a triangle. So, okay, that's going to be 1/2 the base times the height. The base in this case is W times the little height, which is this height right here. Okay, there's the area of the base times whatever the height is. And in this case, the height is L. So whatever the area of the base, there's the area of the base times the height. There's the area of the base times the height. There's the area of the base times the height. Every single time that works just beautifully. But now, let's go to this one. What if it's a cone? What if it's a pyramid? What are you going to do next? Okay, so that makes things a little bit more interesting. So what is the relationship? Well, take a look. The relationship with a cone is very simple. The relationship is the fact that this guy is actually, at one time, was a cylinder. Here you go. But a chunk of that cylinder has been removed. So let's look at the formula of a cylinder first. We know that this is pi r squared and times the height of the cylinder. So there's the area of the base times the height. That's going to be the volume if this was a cylinder. But the only problem is, well, we don't have this portion of the cylinder. We have a cone instead. So what is the relationship? Well, I've got a beautiful video that's going to show you what that relationship is all about. Check this out. The cool thing is there you go. There's the guide. I'm going to pause this for a second. Here's the cylinder in question right here, and here's the cone. And you'll notice that the height of the cone from here to here, okay, is the same height of the cylinder from here to here. You're also going to notice that the circumference of this cone matches this cylinder perfectly. So we're going to try to figure out what is the relationship between these two, okay? So watch what happens. My question is, how many of these cones will it take to fill up the cylinder? So do you have a guess? He filled up this cone with water right now, and he's going to dump it into the cylinder there. My question is, how many of those cones will fill up that cylinder? Do you have a guess? Let's watch the video. Some people may say 2. Well, there's 1, and here he goes. Okay, fills it up again. I'm surprised he doesn't spill anything. There's 2. And then he fills it up a 3rd time, and watch what happens. It goes right up to the top. Look how beautiful that is. What an excellent demonstration here of it takes 3 of these to fill up the original cone. So that's times by 3. So if you had the original cone here, I should say the original cylinder here, how would you figure out how many cones there are? Well, to go from cone to cylinder is multiplying by 3, but to go back, it would be dividing by 3. Awesome. So let's go to our notes now. How do you go from the original? You would have to divide it by 3. So the formula that stands out for us is this one, 1/3 pi r squared times h. There is the formula for a volume of a cone based on the volume of a cylinder. All right, so using this information, let's solve this question. All right, so volume is 1/3. There's pi. Radius here, oh, that's diameter. So radius is half of that. That's 6 squared times the height, which is 18. Okay, pull up our handy dandy calculator. Turn that on, clear the stuff from the previous question. Now, how would you do 1/3 on this calculator? Well, if you have one of those old calculators, you could actually go 1 divided by 3. But the nice thing is here, in this calculator, you can actually put it as a fraction in a bracket, just like that. There's 1/3. You want pi, there's pi. 6 has to be squared, so times 6 squared, okay, times 18. And look at that. The whole thing is done for you in one swift calculation on this calculator. Press enter and look what you got. You got 678.58. So 678.6, 678.6. And what are the units? Well, in this case, it's inches. But remember, you're talking volume. So it's going to be inches what? You got it. Inches cubed. And that's how you solve these kinds of questions.